Welcome back to Step Electrical Friends. Today we are going to discuss nodal analysis. It is just our intro section, so for this we will discuss what is nodal analysis, what is the purpose of nodal analysis, how to solve any circuit using nodal analysis. And for this we will understand each and every steps and trick which will boost our efficiency for solving any circuit using nodal analysis. Finally, we will also see different types of network which we have to face while solving numerical problems. Nodal analysis is a method used in electrical engineering to analyze and solve linear circuits. And here the circuit is. What is the purpose of nodal analysis? Here we will get the idea what we have to find out. So we have to find the voltage potential at each node. These all are the nodes. Nodes are the connection point, and we have to find out the voltage that is potential difference at each of these nodes. Now how to solve and what are the different types of circuits we will discuss later. Okay, so this is a circuit. As we have seen, we have assumed here nodes A, B, C and D. These all are the nodes. How to solve? This is our initial stage for nodal analysis, that we have to assume the nodes, that is A, B, C and D are the nodes, and you have to be very attentive while selecting the nodes. So while talking about nodal analysis is nothing, just the application of KCL and Ohm's law. Okay, so here it is. It is just the application of KCL, and here the voltage is unknown. The node voltage, the voltage at the node A, B, C and D are unknown. So using KCL we find the node voltage. A, B, C and D are the nodes. Now we have to assume one thing, that we see here it is grounded, and this node is known as a reference node. So we assume node D as the reference node. VD is equal to 0 volt. We have to consider that the node on which we are applying the KCL has the highest potential. Okay, this is the thing that we use while solving our network using nodal analysis. Now once again I would like to recall KCL equation, and KCL equation is current entering is equal to current leaving at any node, at any junction. You must have to understand, and we have very clearly discussed in KCL and KVL. Now the second equation that we have to use, that is Ohm's law. From Ohm's law we get I equals V by R. In this section we must have the proper knowledge of source transformation. So here in this given circuit we are given voltage source, and this voltage source may be great headache for us and may cause difficulty while analyzing. So we must have a good knowledge of transforming voltage source into current source. And one most important thing that you have to notice is that is there any resistance in series with voltage source? Here in this network we are given resistor in series with the voltage source, and so we can easily transform this voltage source into current source. So here the transformation is, here this voltage source has been transformed into current source, but how? We have done nothing, just use the Ohm's law, that is I equals V by R. And finally we put this resistance which was in series with this voltage source in parallel with this current source. And this is all about transformation of voltage source into current source. Now see what are the different types of network that we have to face while solving numericals or while solving any problems using nodal analysis. Throughout the nodal analysis we must have to face 4 different types of circuit, and we have to be very careful and think about all of them. We will learn how to solve them in upcoming videos. Now we will only see what are the different types of circuits. Okay, for type 1, circuit containing only current source. Here in this circuit we see that there are only current sources. I1, I2, I3 are the current sources, and it is very easy for us to find out the voltage of the nodes. So here in this circuit we find this voltage source. So we find there is a voltage source, and now you have to think if this voltage source can be easily transformed into current source. Yes, why? Because there is a resistance in series with this voltage source. So we can easily transform this voltage source into current source, and our main motive is to transform this voltage source into current source to avoid extra headache and difficulties while solving this numeric. So this is type 2. In this circuit we see that this voltage source is alone. There is no any resistance in series with this voltage source, so this voltage source can't be transformed into current source. One thing, that this voltage source is involving the reference node. Type 4, The voltage source cannot be transformed into current source. Along with the voltage source is also not involving the reference node. And here the circuit is. This is the circuit. Here this voltage source is not involving this reference node. The reference node is down. This one is the reference node, and this voltage source is not connected with the reference node at any from any way. Voltage source is also not connected with any resistance in series. So this voltage source is neither transformable into current source nor it is connected with the reference node. This is all about the introduction of nodal analysis. Thanks for your attention and patience. If you found this video interesting and enjoyed this learning, so like this video, share this video and drop your valuable comment in the comment box and subscribe this channel. Hope see you in next video.